move on to comparing two proportions. So before we were dealing with means, now we're dealing with proportions. So what is a proportion? Is basically a sample of your sample, right? It's a proportion of your sample. So it's always the same logic, right? We've got a confidence interval, so we've got the point estimate. So this time it's not the difference in means, but the difference in proportions. So P1 and P2. Plus or minus, this time not the t-score anymore, but the z-score. Why is it the z-score? Because we're dealing with proportions. Always very important. Remember this from QM1. When we're dealing with proportions, we use the z-score. What is the z-score? Depending on your confidence interval, so it can be here 20%, 10%, 5%, 2%, 1%. So they're going to tell you in the question, you've got the numbers here assigned to the different levels. So if, for instance, we have a 5% significance level here, we want the z-score, we scroll down and we get 1.96. That's the most common one that we use the most in exam questions and everything, but it can happen that it's 10% or 5% or 1%. Multiplied by the standard error, and the standard error this time is a bit different. So how do we calculate the standard error? It's basically the square root of P1 multiplied by Q1 divided by N1. So what is P? What is Q? P is basically a probability of the event happening. So if they tell you probability has a chance of 3/10, let's say, so P is 0.3. It's 3/10. Then Q, what is Q? Is the probability of the event not happening. So let's say that we had, 3/10 people of probability, then Q is going to be 1 minus the probability, so 0.7. So it's basically a probability of the event not happening. So if P is 0.5, Q is going to be 0.5 as well. If P is 0.4, Q is going to be 0.6. If P is 0.9, then Q is going to be 0.1, right? So on. So it's basically always 1 minus P to get Q. And we do the same with the second sample. So P2 multiplied by Q2 divided by N2. And always N is the number of observation. So for the first and the second sample. All right. I think that's pretty much it for the theory. I prepared for you guys several exam questions. So let's see what you got. How are we gonna work today? So I've got several questions. I think I've got 6 for stats. I'm gonna show you the question and I'll let you a few minutes to work on your own. If you have questions, please send them to me in the chat or speak out loud. It's totally the same for me. And then I'll help you to reach your final answer. If you need, I don't know, the formulas or anything, please text me in the chat. And once you're done, once you think you have the correct answer, you can text me in the chat, in the private chat with your answer. Like this, others are not influenced by your answer. So like this, once you think you have the answer, you can text me in the private chat with the correct answer or the one you think is the answer. And once again, if you have questions, please tell me and I'll help you out. I'll leave you maybe 5 minutes to do this and then we'll solve it all together. And of course, once again, if you're stuck, if you don't know how to start, if you have questions, if you want to, I don't know, for me to show you the formula, of course, please tell me and I'll help you out. I'll guide you through the answer. All right, I'm gonna leave you maybe last minute, the last couple of minutes to work on it, and then we're gonna solve it all together. All right, let's solve it all together. So first of all, let's read the question carefully. So what they basically tell us in the question is that we're looking for a two sample t-test, right? So as I told you, they're always going to state it in the question. So two sample t-test. And they tell you that there are 26 degrees of freedom, as you can see there. We want to know the 95% confidence interval. And yeah, that's pretty much it. So let's get it done. First of all, what is the formula for a confidence interval? It's the following one, right? We said we're using a two-sample t-test. I showed you at the beginning. So point estimate plus or minus t-score multiplied by the standard error. First thing we can do here, so point estimate, the difference between the two means. We can see here the mean of female is 91.92 and the mean of male is 110.167. So we can directly just do 110.167 minus 91.92. That's already our point estimate. Then we can also compute our standard error. So how do we compute this? It's just the square root of the standard deviation squared divided by n1 and the square root of the standard deviation, squared divided by n2, and that's basically the standard error. But we can also check what our t-value looks like, because they tell us that we have 26 degrees of freedom, we have a two-sided test, as they tell us here, two-sided 26 degrees of freedom and 95% confidence interval. So we will have, for sure, a 5% significance level with 26 degrees of freedom in a two-sided test. So let's check it out. Let's go to the table, as you can see here. So we go 5% here, two-sided, perfect. We scroll down until reaching 26 degrees of freedom, and there it is, 2.056. So this here is our t-value that we'll be using for the test, for the confidence interval. So very good. We've got the point estimate, the difference between those two numbers. We've got the t-score. Let's now calculate the standard error. So the standard error, we just plug in the numbers. So 11.754 standard deviation, remember, very important. Squared divided by the count, so number of observation here, 25, plus 9.562 squared divided by 12, so number of observation of the second sample. If you plug this into a calculator, you get roughly 3.6256, so more or less, right, roughly. And then once you plug in all the numbers, so 110.167 minus 91.92, which is 18.247, plus or minus to have both sides, the upper and the lower side of the confidence interval, 2.056, the t-score we just found previously, right, 2.056 here, multiplied by 3.6256, the standard error that we calculated a few seconds ago. And once again, if you plug this into a calculator and you do 18.247 minus that, you get 10.8 roughly. And if you do plus that, you get 25.7. And thus the answer is B. Is this clear for everybody, or should I go over it once again, or a specific step once again? You can tell me in the chat, and if it's fine, we can then move on to the next question. But if you have questions, please, guys, don't hesitate to tell me. All right, I see no questions, so that's pretty good. We can then move on to the second one. So, okay, I see a question here. Why did I get the study error if they give it to you? So basically, here they give you the standard error of the first sample and the standard error of the second sample. What we want to know here is the standard error of the entire model that we want to calculate. Yeah, exactly. It's because just from one sample. Very good in the chat. So yeah, we want to know the standard error of the entire model, of the entire survey, if we can say so, not only of male and female. That's why we take the standard error of the entire model, and that's how you calculate it. You cannot just take 2.351 plus 2.760. It doesn't work out like this. You have to calculate properly the new standard error of the entire model. I hope this answers your question. All right, moving on then. I'll let you read this small text as if you're in the exam, and then check which of the following statements is or are true. And once you're ready, once you have your answer locked in, you can send it to me in the private chat. Right, so a few more seconds for this one, maybe waiting for a few more answers, and then we'll be ready to correct to solve it all together. All right, very good job, guys. So here, let's read the question all together and check which of the these statements are correct or is correct. All right, so I just answer in the chat. So for those who still send me their answers, perfect. So what can we say based on the text and the graph they give us? So shape up by Susie, blah, blah, blah. We don't care about this. She is guaranteeing you a weight loss after 6 weeks. So 5 clients weighed themselves before and after participating. So we know for sure, if you remember what I said a few minutes ago, if you have something before and after, that's always, always, always a paired t-test. So we know for sure statement 1 is correct. That's a paired design, a paired test, a paired t-test, call it whatever. Great, however you want, it's paired. Now what we want to check is is it one-sided or two-sided? So that's the big question, what we're gonna assess here. So t-test of mean difference equal to 0. So I told you the null hypothesis will always be that the difference of the mean is 0. And this time the alternative is that the difference of the means is lower than 0. In other terms, after the program, your mean of the weight will be lower than before the program. So it makes sense, right? They say that because you participate in the program, you're gonna lose some weight. So the mean of the weights will be lower in the group 2, so after than before. That's basically the aim of the entire program, right? That there is a difference in mean, that the second mean is lower, than the first one. So as we said, when the alternative hypothesis is that one mean is lower or higher than the other, it's always one-sided, right? So in that case, the correct answer is both 1 and 3, so answer E, are correct. If it had been that the alternative hypothesis, so HA, is that mu1 is different from mu2, then we would have said, indeed, 2 is also correct. And then the final answer would have been both 1 and 2, so D. But in that case, we only want to know if it's higher or lower in that case. So we want to know a one-sided test or one-tailed test. These are synonyms. Is it clear for everybody? Or should I go over it once again? Get it? Perfect. That's what I like to see. So let's see if you actually get it.